Okay, guys, let's talk about section 4.5. So with this section, we're going to talk about solving exponential and logarithmic equations. Okay, so one of the properties that we have on logs, and it is very, very similar to the one that we had in the exponential. Okay, so first off, we've got to make sure that all of our rules for logs are going to be followed. Okay, so we're going to take x is greater than 0, y is greater than 0, a is greater than 0, and a is not equal to 1. Then log a of x equals log a of y. Okay, then x equals y. So we saw the same thing when we did exponentials. Okay, we did a to the x equal, or I think it was a to the b equals a to the c. B had to equal c. Now we've got that if we have log a of x and log a of y, we can basically cross off the log words for this. Okay, so now then, we're going to see this used here in just a little bit. Okay, now one of the things that we're going to look at on the problems that we're doing here, and we're gonna reach back into exponentials here for just a little bit. Okay, we worked on the last time using that whole a to the b equals a to the c. That meant that b had to equal c. Okay, now what we're going to look at is what happens if I can't get them into the same base. Okay, so we have something like 7x equals 12. Okay, what we are looking at here is going to be that we need to get the x down out of the exponent. Okay, and again, we talked about when we discussed logs, okay, that we needed to have it. Now, one of the options that we have, because we are going to try and solve for this, okay, is going to be that we need to get this x down. One of the ways that we know to do this is we've talked about the power rule in logs, where if I had log base a of x to the r, that could come down out in front like this. Now, the problem that we have is right now, I don't have log on this. Okay, now you have to remember that log is an operation, kind of like square root or cube root or something like that. It's something that you do. So you can take, and I'm just using natural log here just for reference. So I can take log on both sides, and I will still have kept this in an equivalent statement. Now I can bring the x down out in front. Okay. Now, x and natural log are just connected using multiplication. So now I can divide the natural log of 7 over to the other side. Now, two things. One, you cannot cross off natural log. Okay? This is not 12 over 7. That is not the way this works. Okay? Two, this is not the same as this. Okay, these two things are not equal. You cannot just bring the natural log or a log out in front. Now, the other thing is, this is called an exact answer when you still have things done where you leave the word log in it. Kind of the same way that if I wanted an exact answer, I would leave things like square root of 5 in my problem, okay, because square root of 5 does not come out to be a nice clean number. So now, putting natural log of 12 and making sure that I close that set of parentheses, and then natural log of 7 onto my calculator, we get that this is 1.27699. Okay, now this is a decimal approximation. Okay, and guys, they will tell you, or they should indicate, how many decimal points they ask you to go. Okay, how many decimal places they want you to go with that. So we have that basic idea. So now, taking a look at one that is going to be a little bit more involved. I'm trying to give myself a little bit more space here. Now, first off, okay, you can automatically recognize we're not going to get these to the same base. It's not going to happen. Okay. Now, the other thing that makes this challenging, or more challenging than the last one, is the fact that there are x's in both exponents that are happening here, okay? So I'm going to use natural log again, okay? And we're going to process from there. So again, first thing I need to do is bring natural log into the mix. And again, I'm going to bring down my exponents. Okay. Now, the concern, now problem one is been handled. I've got the x's down out of the exponents. Now, problem number two is I need to get all of my x's onto the same side. At this point in time, the only way I can move stuff around is I could divide one of these x pieces over into the other, and that's going to make a fraction, and that's not going to help us. So what we're actually going to do is distribute okay? And now I'm going to get all of my x things on one side and my non-x things on the other. So I'm going to bring this over here, and I'm going to take this natural log and move it that way. I'm going to have 2x natural log of 3. I'm going to subtract that x natural log of 0.4 over. I've got 2 natural log of 0.4, and I'm going to add that natural log of 3 back over to the other side. Now, similar to when we solved our rational problems back when we were doing inverses, I'm now going to factor my x out of this. Okay, and then we're going to divide. Okay, so now this again, this would be my exact answer. Okay, kind of processing with that. Now then, what I will encourage though on this, okay, do not try to put this all in on a calculator at one point in time. Okay, do not. Okay, do this in 2 parts. Get the top part, being careful to do parentheses everywhere that they need to happen. Okay, get a single value for that. Do the bottom. And then go back and do the division. Okay. Okay. And I am getting negative 0.236, we'll call it, okay? Now, one of the things that you can always do, okay, is you can take this and you can plug it back in for x up here at the top end, okay, way back up here at the top end, okay? You can take that answer and plug it back in up here and make sure that it is indeed giving you, okay, the right answer, okay? Now, bear in mind, it may be a little bit off because of you are doing an approximation, but it should be pretty stinking close, okay? So now let's take a look at another one, okay? So e to the x squared equals 200. Now, sometimes we have problems, okay, where one log version is going to work better than the other ones, okay? Anytime you have a base of e, you want to use natural log against it, okay? And that is because when you have e against natural log, they cancel each other out, okay? So this now leaves me x squared equals natural log of 200, okay? So then x is going to be the square root of natural log of 200. And again, that would be exact. This is going to be 2.302 roughly. Now, because we've done the plus and the minus, or we brought in the square root, we would also need to bring in plus minus for this, okay? And this is not going to be a problem because when it goes back in, we're going back into an exponential thing, okay? Now, another example, okay, and this one was not in my PowerPoint, okay, would be something like this, okay? Guys, if you've got a base of 10, you want to use common log against that, okay? Now, on the previous problems that I did, like the 7 to the x and the 3 to the 2x minus 1, those two problems, you could have used common log, okay? You can use either one. I use natural log just so that you can see what's going on. But whenever you have a base of 10, remember that common log has a base of 10 as well. So these two cancel each other off. So now I have x plus 7 equals log 84. Now with this one, you would want to be really, really careful. Okay? Either stick you a set of parentheses around that 84 to say you're done with that, but do not do 84 minus 7. Okay? So if I was going for an exact answer for this, okay, so again, this is exact, and this is our decimal approximation, okay? Okay. Okay, now another thing that comes back up, okay, is they can bring back those quadratic looking equations that we saw back over in that mixed section, okay, where they had like 5 or 6 or 7 different types of equations. So with this one, okay, we're going to set up that replacement thing. So I'm going to let u be e to the x, which means u squared is e to the x squared, which is e to the 2x. So I now have that this is u squared minus 4u plus 3 equals 0. Okay, and now we're going to solve. I am going to factor this one. So it's going to go to u minus 3, u minus 1. So we're going to take u minus 3 and set it equal to 0. U minus 1 and set it equal to 0. Now, finish solving. Okay, problem is I'm still in the letter u. Okay, so we need to switch that back. So u was e to the x. So e to the x equals 3 and e to the x equals 1. So now we're going to finish solving with this. Again, we're going to bring in natural log. Okay, natural log against the e's will go away. So it's going to give me x equals natural log of 3 and x equals natural log of 1. Now, this question did ask for things to be done in their exact answers. And if you put this in on the homework platform, okay, and you put in natural log of 3, natural log of 1, it's going to come back and tell you that's incorrect, okay? And it's not because any of your math is wrong, okay? Guys, natural log of 3 is not a pretty answer. However, natural log of 1 is 0. Okay, and 0 is a pretty answer. Okay, so this would be what you're putting in on a calculator. It is not going to want you to put natural log of 1 as a response to what's going on. Okay, now those are pretty much all the types that you're going to see on the exponential stuff. So now we're going to look at the log stuff. Now, with the log stuff, when we're solving log equations, okay? So for log equations, okay, there's going to be two types, okay? We're either going to switch format, okay, which means we're going to do our e-loop thing, okay? Or we have logs on both sides, okay? And that's going to use that rule that we had right up there at the beginning of stuff, okay? That's going to bring up the one where they were talking about log base a of x equals log base a of y. X has to equal y, okay? So we're going to start this out. Now, first example. Now, first thing is, okay, and we're starting with the switch sides version, okay, is we need to get the log thing by itself. So we're going to divide by 7 here. Now, I do have the option that I could put the 7 back up as an exponent, thinking about that power rule. The concern that I have with that is that's going to give me x to the 7th. And then I've got to do a 7th root later on. I really don't want to do 7th roots. So also this divides pretty. So we're going to divide through. So divided by 7, okay. Now we're going to loop this, okay. So we're going to loop out. Remember that the base for this is e because it's natural log. Okay. And again, this is considered an exact answer. This one actually wants this answer in exact form. The other thing is you could put e to the 4th on a calculator if they asked for a decimal. Okay. So now, let's look at another one. Okay. Now, this one's already in a nice, pretty formatted thing that we have. Okay, so we're going to loop this out. So I have 2 cubed equals x cubed minus 19. So I have 8 equals x cubed minus 19. I'm going to add my 19 back over to the other side. I've got x cubed equals 27. And then I'm going to take a cube root on both sides. So we've got x is 3. Now, one of the things you have to check on logs is you have to make sure that the answer you're getting when it goes in is not going to make a problem. So 3 cubed is 27 minus 19 is 8. We're good. We're not taking the log of 0. We're not taking the log of a negative. Okay. So let's take a look at another one. So we're going to loop this out. So I've got 2 cubed equals 3x minus 7, x minus 4. So now we've got 8. And guys, there's not going to be a way for us, so we're going to need to just multiply this out. So we've got 3x squared. It's going to be minus 12x minus 7x. That's minus 19x. Plus 28. Okay. Drag the 8 back over to the other side, seeing as how it's quadratic. Okay, let's do a little box here. 3x, 20. I'm trying to get to 60 and negative 19. So 1 and 60, 2 and 30, 3 and 10, 4 and 15. Okay, that's going to be my set right there. So I've got 4x, negative 4x, negative 15x. So it's an x, 3x minus 4 minus 5. Okay, so we've got 3x minus 4 and x minus 5. Okay, so 3x minus 4 equals 0. X minus 5 equals 0. Now, got to check our stuff in. Sorry, that looks really sloppy. Okay, so we're going to check stuff back in. So I'm going to start with the easy one. I'm going to start with 5. 3 times 5 is 15, minus 7 is 8. That's okay. 5 minus 4 is 1. That's okay. Okay, so we're going to keep this. Now, 4/3. 4/3 times 3 is going to be 4. 4 minus 7 is -3. Okay, so we're going to have to check this. Okay, so because guys, again, we can't take the square root of 0. We can't take the square root of a negative up here. Okay, so we need to make sure that this isn't going to mess up. So that's -3. And then we have 4/3 minus 4. Okay. Okay. Now, when I put this over here, 4/3 minus 4 is also negative. But y'all, negative times negative is going to turn positive. So we're okay. Okay. We are actually good with both of these. Okay. So now, one of the things that sometimes happens with these, okay, is, and they haven't shown us one of these yet. Okay, sometimes you've got to do a bit of condensing before you can do your loop out. Okay, I've got 2 log words on this side. Okay, so I need to actually combine these together using my product rule. Okay, so I use my product rule that log plus log goes back to multiplication. And now I'm going to loop this out. Now, this is common log. Common log is a base of 10. So, it's going to be -3 plus 2 is going to be minus an x. We're going to add, or excuse me, subtract that over. Okay, let's see. -3, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Okay, this one actually won't factor. Okay. So we're going to have to go to quadratic formula with it. This will be fun. Okay, so -1 plus minus the square root of -1 squared minus 4 times 3 times -12 all over 2 times 3. So we've got 1 plus and minus. Okay. Now, with this, okay, my only concern is getting it plugged back in and making it work. So while they want exact answers to this, I need to make sure that these are going to work out. So I'm going to actually figure out the decimal version of this. Okay, so I'm going to start with the positive. And I get 2.17 roughly. So a little bit over 2. So it'll be a little bit more than 6. Plus 2 will be a little bit more than 8. A little more than 2 minus 1 will be a little more than 1. So I'm going to agree with the positive one. The negative, or the subtract version, is -1.8. Okay. 3 times -1.8, or not even doing it here, -1 point something minus 1 is going to be -2. So I cannot have the negative version of this. So I am only the positive version of this, okay? And again, that's because when I took this, the negative version of this, or the subtract version of this, is negative 1.8. And if I put that back in up here, negative 1.8 minus 1 is negative 2. You cannot take the log of a negative, okay? So the subtract, regardless of what happened up here, it messes up on the second one, okay, at a minimum. Now, the next time that we're going to do, okay, is going to be when we have logs on both sides, okay? Now then, the question always comes up, okay, because this first one also has to do some condensing in it. Okay, is how do I know when I recognize that it's a switch format, and how do I know when it's a log on both sides? The answer is if everything has a log word on it, it's going to be a log cross off. Okay, if there is one item that does not have a log word on it, then it is a switch format. Now, you are not allowed to cross off log at this point in time. The only way that rule works, okay, is when you have a single log on one side and a single log on the other, okay? So the first thing we've got to do is condense this side. So subtraction goes back to division. Okay, and then we're going to get to cross off the log on both sides. So we're going to have x plus 6 over x plus 2 equals x. Okay, and now I can move. I'm going to multiply that x plus 2 back over to the other side. So we've got x plus 6 equals x squared plus 2x. I'm going to drag everything over. We're going to subtract an x, so that's going to give me plus x, and subtract a 6. Factoring, I've got x plus 3, x minus 2. Okay, setting each one equal to 0. Can you... just for a second? Okay, so I've got negative 3 and 2. Okay, so now if I bump back up, okay, and we check this stuff in, negative 3 plus 6 is 3. We're good with that. Negative 3 plus 2 is negative 1. That's out. Okay, also if I plugged it over here, that's negative 3. You cannot take the log of a negative number. So now then 2 plus 6 is 8. That's fine. 2 plus 2 is 4. That's good. And 2 is over here. Now, do be mindful, okay? I am not saying by any means, okay, that you cannot have negative numbers, okay? An example would be, okay, if, let's say this would have been x plus 4 over here. Okay, let's say this has been an x plus 4 way over here. And I had gotten something like x equals negative 1 as a solution. Negative 1 plus 6 is 5. That's good. Negative 1 plus 2 is 1. That's good. Negative 1 plus 4 is 3. That's good. Okay? As long as when you take the number and plug it in, every log piece is going to come out. Okay? You're fine. Okay? So do not think that just because you get a negative number, it is automatically out. Okay? That is not the scenario that we are presenting here. Okay? So now then, taking a look at another one. And why they stacked this the way they did, I'm not real sure. Okay, not real sure why they stacked this the way that they did. Okay, because the first thing I notice is natural log against E. Those go away. So now I've got natural log of x minus natural log of x minus 3 equals natural log of 2. Not really sure why they did this, okay? Again, though, I've got too many logs on one side, so I am going to condense those. Okay. Now, do be careful, okay, when you're doing your condensing, okay? I now have natural log on both sides because I can bring that off. So I have x over x minus 3 equals 2. I'm going to bring this back over. I'm going to bring the x back this way, and I'm going to drag the 6 back over to here. So I've got x equals 6. Now I just need to kind of make sure that all of that's good. Natural log of 6 will be okay. That'll come out to be a value that's e. So we'll do natural log of 6 is 1.79. E to that answer is 5.99, so that's back to 6. That'll be natural log of 6. It'll be fine. 6 minus 3 is 3, so that's good too. So we are good with keeping this answer, okay? So again, we have seen in solving exponentials, we saw two formats, okay? So let's recap here real quick. Exponentials, we did a to the b equals a to the c, means b equals c. The other format was use a log, okay? And that was when you could not get your bases to match. This is the type that we started this section with, okay? Now, when you're in log, we talked about switch format, okay? And that's where you're going to have log on one side equals something else, and you are going to loop that out, okay? The other one was log on both sides, okay? And that's where we're using the fact that the log and the log can go away, and that leaves me x equals y. Okay, so those are kind of the two that we have. Now, we're going to take a look here at a couple of application ones, just so that you can see a couple of these where you would be using these to help us solve. Okay, so they are talking about the strength of a habit. Okay, so any sort of a habit, whether it's biting your nails or you know, how you set your day up or whatever else, okay? So the formula okay, looks like this. And they ask us to solve this equation for K. Now, first thing I'm going to do is divide off the 1,000, back off from the front end. Okay. Then I'm going to subtract the 1. And I'm going to divide by -1. So that's basically just switch everything. Now, just for sake of making this a little bit cleaner, I'm going to put the 1 up here in the front of this so that it leads with a positive number. Okay. Now, I need to get rid of the e over here. Okay, so we're going to bring natural log into the picture. Sorry, there's still a negative up in the top end of these. Okay. Sorry. I had another marker color. So those are going away. So now I've got natural log of 1 minus h over 1,000 equals -k n. And I'm going to divide off the -k. So natural log of 1 minus h over 1,000 over -k equals n. Maybe just slightly out of frame. Okay. And there would be my answer for that one. Okay. Now, this next one, so notice where we use natural log in this to help us solve. Okay, so that was kind of using log to help us solve an equation. Okay, so that was kind of solving an exponential equation using a log to help us out there. Okay. Now, this next one, they gave a table that gave coal consumption for the United States, but they gave us the equation okay, and T is years after 1900, okay? And then F of T, or the Y value in this, is quads, and this is quadrillions of British thermal units, okay? Slowly, isn't it? So it asks approximately what amount of coal was consumed in 2003. Okay, so that would be just a straight plug in. Now, that means T equals 103, just so that we're well aware of that. So that's going to be 24.92 natural log of 103 minus 93.3. Now, do make sure you are being careful with this when it goes onto a calculator, okay, that you're closing up that parenthesis after that 103. Sorry, let me have one on it. Okay, and I'm getting that this is 22.187 roughly, and it says, how does this compare to 22.32? This was the actual. It's a little under, okay, but it's fairly close, okay? Now, the next question that it asks is, when will it reach 25? Okay, so for that, we're going to set 25 equal to this value. Okay, so I'm going to add the 93.31. We've got 118.31. Okay, I'm going to divide by that 24.92. Now, I'm going to write this, okay? Now, guys, I'm going to switch these sides so that you can see what I'm fixing to do. I am going to let my calculator have this full decimal number that's fixing to happen. Now, the reason that I switched that over, this now has log, single log on one side, so I need to E-loop that. So this is going to be E to that 4.7475 number, and that's going to equal T. So I'm going to do E to that value, and I'm going to get that T is 115.3. And again, since that is years after, I'm going to say that that's going to be 2015, maybe 2016. Kind of, again, we've talked about these in the past. When these are timed, did they take the count at the beginning of the year, or did they take the count at the end of the year? Okay, so hope this helps you guys out with section 4.5.